Okay, so now we're going to start reviewing for our ratios unit and some basic information before we begin. Start here. What is a ratio? A ratio is a comparison of two units or two quantities that have different units. A proportional relationship is compares two ratios, and if their relationship is proportional, then those two ratios are equal. So that's going to take us right down here to 3. How to prove if two ratios are equal? So we want to know, is 2/3 proportional to 5/6? And the way that you check if two ratios are equal or proportional is you cross multiply diagonally. I'm going to do 6 times 2, which is 12. The answer is butterfly lane. And then 3 times 5 is 15. Since 12 is not equal to 15, 2/3 is not equal to 5/6. So those ratios are not proportional, 2/3 and 5/6. If our cross products were equal, then we would have known that they are proportional. So for example, 2/4 being compared to 6/12, if I did 12 times 2 is 24, and 4 times 6 is 24. I know that these are equal, so I would say yes, 2/4 is proportional to 6/12. So now, step 4 says how to create an equal ratio if you have one ratio. So here I have a ratio of 3/7. One way that you can create an equal ratio is by multiplying top and bottom by any same number. So I'll start with times 2, and this will become 6 over 14. So now I know 6/14 is equal to 3/7. Another way to create an equal ratio, if you already have a ratio, is to divide top and bottom by the same number. So if I divide it by 2, and 6 divided by 2 would be 3, 14 divided by 2 would be 7. So if I started with 6/14, I could have turned it into 3/7. Either way, to create an equal ratio when you already have one ratio is multiply or divide top and bottom by the same number. You're either multiplying numerator and denominator by the same thing or dividing numerator and denominator by the same thing. Now we're going to take a look at how you can write a ratio. So there's 3 different ways, 3 different types of ratios and 3 different ways to write a ratio. Here's one thing. The first thing here says, what's the ratio of apples to bananas in this picture? Because they put the word apples first, you have to put the number of apples first. I see 1, 2, 3, 4, 5, 6 apples to 1, 2, 3, 4 bananas. Another way that I could write that is 6 to 4 or 6 over 4. But in all 3 cases, apples or the number 6 had to come first because the word apples came first when they asked. When they then ask in number 2 for bananas to apples, it would be 4 to 6 because you put the number of bananas first. After that, they ask apples to total fruit. Well, there are 6 apples to how many pieces of total fruit? 10 pieces of fruit in all. So that would also be 6 to 10 or 6 colon 10. In any case, apples comes first and total number of fruit comes second because they put the word apples first and the word total fruit second. Bananas to total fruit would be 4 to 10 because there are 4 bananas and 10 total fruit. And that's it. We already did this on the last slide. So the last thing that we're going to look at today is how to create a proportion from given information and solve it using 2 different strategies. So here I see I run 12 feet every 3 minutes. How many feet can I run in 9 minutes? Well, this information, 12 feet every 3 minutes, that's a rate. So I'm going to set that up as a ratio. 12 feet every 3 minutes. So a ratio, remember, is comparing 2 different quantities with different units. So here I have a ratio set up as a fraction, and it's comparing feet to minutes. So then, how many feet can I run in 9 minutes? Well, to set up a proportion, I know it has to be an equal fraction. And the only other number that this problem gives me is 9 minutes. So I'm going to take that 9 minutes and place it on the bottom because here on the left I have minutes on the bottom, so on the right I need minutes on the bottom. And whatever answer I get is going to be in feet because feet will stay across from feet. So it's still going to be feet compared to minutes. So it's feet on top and minutes on the bottom. Now if I set up this proportion from the given information, there are 2 different ways that I could solve this. One way is looking at the relationship from one denominator to the other and just repeating that relationship up top. Why not to turn a 3 into a 9, I have to do times 3. So if I did times 3 up top, 12 times 3 would give me 36 feet. So it looks like I can go 36 feet every 9 minutes. Now we just set this up again and solve it a different way. Make sure they get the same answer using 2 different strategies. Because sometimes you might have numbers on the bottom that you don't know how they turn into each other, or you can't see the relationship, in which case you want to use cross multiply then divide. So if I didn't know how to turn a 3 into a 9, I would simply, once I have 3 numbers plugged into any proportion and I'm looking for one x variable or one missing unit, I always cross multiply whichever 2 units are diagonal. So here I have 9 and 12 diagonal from each other, so I'm going to multiply 12 times 9. 9 times 2 is 18, 9 times 1 is 9, plus 1 is 10. So I get 108. And then divide. And what you divide by is the only other number that you didn't use yet in the proportion. So I cross multiplied my 2 numbers diagonal, and I got 108, and then I'm going to divide that by 3. So 108 divided by 3. 3 can't go into 1, 3 goes into 10 3 times, minus 9, I get 1, and 3 goes into 18 6 times. 1 into 18, I get nothing. So it looks like I got x equals 36. Same answer, 2 different strategies. So you can repeat the relationship from numerator to numerator and denominator to denominator, or you can use cross multiply then divide. There is one final strategy, and I'll quickly show it just as a bonus so that you know you actually have 3 different options to solve any proportion. So the last thing, I'm just going to reset up the proportion that they gave me really quickly. So they told me 12 feet every 3 minutes, and they want to know how many feet will that be in 9 minutes. One other thing that you could do is, since I have both denominators, I could say, how does this denominator turn into this numerator? To turn a 3 into a 12, I have to do times 4. So on this denominator, I can do the same thing to turn it into this numerator, times 4. 9 times 4 is going to give me 36 feet. So 3 different ways to get the same answer. Either repeating the relationship between denominator to numerator, or repeating the relationship from denominator to denominator and numerator to numerator. And if you don't see any relationships at all, you can always scroll back on cross multiply the 2 units that you have diagonal, and then divide that answer by the 3rd unit. So those are 3 different ways you can solve a proportion. Please use this to study for your test, and happy Tuesday.